For millions of years, the ancient oceans were ruled by a predator so vast and powerful that even modern great white sharks would have seemed insignificant beside it. Megalodon was not just one of the largest sharks that ever lived. It shaped entire marine ecosystems, influencing everything from migration patterns to survival behavior. Imagine a time when the oceans were deeper, warmer, and filled with creatures far larger than anything alive today. In this world, Megalodon was not merely surviving, it was the undisputed master of the ancient seas. Megalodon lived during a warm period of Earth's history, known as the Miocene and early Pliocene, roughly between 23 million and 3.6 million years ago. The oceans were deeper and more stable than today. Large marine mammals such as ancient whales, seals, and sea cows were abundant, turning the ancient seas into enormous hunting grounds. The climate was warm and the sea level was higher, creating broad, shallow bays where life flourished along extended coastlines. In this environment, Megalodon had access to abundant food and global habitat, making the ancient oceans the perfect place for a superpredator to rise. Megalodon evolved from a long lineage of large ancient sharks that began dominating the oceans more than 60 million years ago, shortly after the extinction of non-avian dinosaurs. Early shark ancestors were smaller and shared the prehistoric oceans with massive marine reptiles, but as marine mammals became more common, the need for stronger and more efficient predators increased. Over millions of years, Megalodon developed a massive streamlined shark body, powerful jaw muscles, and serrated teeth designed to bite through thick whalebone. This evolutionary path made Megalodon not only larger, but also more specialized in hunting large marine mammals, turning it into the top predator of its age. Megalodon lived in oceans across the world, from tropical coastal waters to deep offshore environments. The ancient seas were warmer, calmer, and filled with large marine mammals, giving Megalodon both abundant food and wide territory. In shallow coastal regions, herds of marine mammals often migrated together, creating predictable hunting patterns. In deeper waters, Megalodon moved slowly and silently across vast feeding grounds, using its enormous size to patrol entire ecosystems. This global habitat allowed Megalodon to thrive for millions of years and remain the dominant predator wherever it traveled. Megalodon dominated ancient oceans with unmatched size, strength, and strategic hunting behavior. Its enormous body allowed it to patrol vast feeding grounds, while its immense bite force made it capable of killing large marine mammals with a single strike. Unlike smaller predators, Megalodon did not need to chase prey over long distances. It could wait near migration routes, coastlines, and deep water passages until marine mammals passed by. Its dominance came not just from power, but from patience, intelligence, and control over entire ecosystems. Megalodon fed primarily on large marine mammals, including prehistoric whales, dolphins, and seals. Its size, strength, and powerful jaws allowed it to consume huge amounts of food with minimal effort. Instead of chasing prey across long distances, Megalodon often waited near migration routes or coastal feeding zones where marine mammals gathered in groups. By targeting slow or vulnerable individuals, it preserved energy and maintained dominance without constant pursuit. This efficient feeding strategy helped Megalodon stay at the top of the ancient marine food web for millions of years. Megalodon, like many large sharks today, likely gave birth to live pups rather than laying eggs. Evidence from modern shark biology suggests that newborn megalodons were already extremely large, possibly between 2 and 4 meters long, which made them bigger than most adult sharks alive today. Young megalodons were believed to grow within sheltered coastal nurseries where shallow waters, abundant food, and reduced competition increased survival rates. As they matured, adolescents migrated into deeper hunting zones, gaining size and strength over many years. Adult megalodons were enormous, reaching an estimated 14 to 18 meters in length and weighing more than 30 to 50 tons. Their lifespan may have extended 40 to 60 years or longer in stable conditions. They carried more than 250 serrated teeth, perfectly adapted for biting through bone, making them one of the most powerful marine predators ever known. This remarkable life cycle allowed Megalodon to grow from massive newborns into adults capable of dominating entire ocean ecosystems. Megalodon survived and dominated for millions of years because it relied on energy-efficient hunting, selective feeding, and strategic positioning. Instead of competing constantly for food, Megalodon occupied large territories where marine mammals migrated naturally. It used slow movements, patience, and careful timing to conserve energy while remaining ready to strike when opportunities appeared. This calm and deliberate strategy allowed Megalodon to thrive without unnecessary conflict or constant pursuit, making it one of the most successful predators in the history of ancient oceans. Although Megalodon was the dominant predator of its era, it did not exist without natural challenges. Its main competitors were other large marine predators, including massive toothed whales and early forms of giant sharks. Some prehistoric whales traveled in coordinated groups, making them more difficult for a single predator to attack successfully. Strong social behavior allowed these marine mammals to protect younger or injured members by surrounding them during migration. In deep water environments, Megalodon also faced environmental risks such as limited visibility, sudden ocean currents, and unpredictable territory changes that affected its feeding patterns. Competition, environmental conditions, and occasional confrontations helped shape Megalodon's survival strategies and influenced where it chose to hunt. Throughout Megalodon's existence, the ancient oceans underwent significant environmental changes that impacted food availability and migration behavior. Rising and falling sea levels reshaped coastlines, altering where marine mammals gathered and how far they traveled each season. Shifts in global temperature affected water chemistry, plankton distribution, and the population size of marine mammals that Megalodon relied on. In colder periods, prey became harder to locate, forcing Megalodon to explore deeper waters or migrate longer distances. Sudden environmental disturbances such as volcanic activity, strong underwater currents, and shifting sediment also influenced visibility, feeding patterns, and the difficulty of hunting. These natural changes required Megalodon to adapt, adjust its territory, and remain flexible in how it found food across millions of years of evolving oceans. The extinction of Megalodon was not caused by a single dramatic event, but by a long series of environmental changes that slowly reshaped the ancient oceans. As global temperatures cooled over millions of years, marine mammals migrated differently and began gathering in smaller groups, reducing the food supply that Megalodon depended on. Shifting ocean chemistry affected plankton distribution and caused major declines in prey populations, especially in regions where coastal feeding used to be abundant. Tectonic movement and frequent underwater earthquakes altered the seafloor, creating new deep channels, unstable sediment layers, and unpredictable migration paths. Volcanic disturbances and sudden changes in water temperature disrupted visibility, feeding behavior, and long-distance navigation. Over time, competition from new marine predators increased, and the availability of slow or isolated prey became rare. Reduced food supply, long-distance travel, and changing migration patterns made it difficult for Megalodon to sustain its massive energy needs. Instead of a sudden disappearance, Megalodon slowly faded from the ancient oceans as ecosystems evolved and marine mammals became less abundant. Its extinction reflects the natural transformation of Earth's oceans and the gradual decline of a once dominant and powerful predator. Everything we know about Megalodon comes from scientific evidence preserved in the ocean floor and coastal sediments. Because shark skeletons are made mostly of cartilage, they do not fossilize well, which means the most reliable remains are teeth, jaw fragments, and rare vertebral sections. Megalodon teeth are among the largest ever discovered, measuring up to 18 centimeters in height, and their distribution across multiple continents confirms that Megalodon inhabited nearly every major ocean. Scientists analyze tooth growth patterns, wear surfaces, and chemical composition to estimate diet, migration routes, and environmental conditions. Marine sediment samples reveal ocean chemistry at different points in time, helping researchers understand when food became scarce and why population numbers declined. Modern underwater mapping and core drilling continue to uncover new fossil layers, demonstrating that scientific research is ongoing and far from complete. These discoveries allow us to reconstruct a detailed picture of a prehistoric world, once ruled by one of the most remarkable ocean predators in natural history. If you enjoyed this journey into Earth's prehistoric oceans, consider subscribing for more calm, educational documentaries exploring ancient life, natural history, and scientific discovery. Your support helps us continue creating thoughtful content that brings the past to life through modern research and realistic visual storytelling.